The Fermi paradox essentially queries, why haven't we heard from anyone out there? And why weren't we included in the cosmic conversation? One of the potential explanations for our solitude in the vast expanse of space is the concept of the Great Filter. This idea, introduced in the 1990s by Robin Hanson, postulates a significant barrier or challenge that may prevent life from proliferating across the cosmos. This Great Filter is a metaphorical sieve that civilizations might need to traverse to achieve the kind of advanced state we often fantasize about in sci-fi tales. You've probably seen something like this in the game about Captain Shepard. Regrettably, evidence of such advanced civilizations or even basic extraterrestrial life remains elusive. It could be that evolving into higher life forms or mastering interstellar travel is a monumental task. Such an impediment might halt civilizations from progressing, either due to natural cataclysms like asteroid hits and ecological crises, or by their own actions leading to self-destruction. Analyzing this theory, we face two intriguing possibilities. The first suggests we've already navigated past this daunting filter, meaning we've weathered the toughest trials of existence. Yay for us! But this would imply that intelligent life is a rare gem in the vastness of space, leaving us potentially unique and isolated. So our dreams of interstellar friendships and explorations might be just fantasies. On the gloomier side, the second possibility posits that the most challenging tests lie ahead, indicating that while other civilizations might exist, they too face challenges they've yet to overcome. They, like us, might be striving to survive, evolve, and hoping to signal to the cosmos that they're here. Within the discussions of the Great Filter, there's mention of the rise of artificial intelligence, AI. With AI's rapid advancement, it's conceivable that it might turn out to be a double-edged sword for humanity. AI, as highlighted by the Great Filter theory, presents both an opportunity and a challenge. As this technology surges ahead, becoming increasingly integrated into our lives, there's a growing concern about its unforeseen consequences. If not handled responsibly, AI could end up being one of the hurdles civilizations, including ours, struggle to surpass. The potential for AI to reshape our society and even pose existential risks underscores the importance of cautious advancement. Yet, it's crucial to remember that the universe is vast, and the narrative isn't solely one of doom and gloom. There's a silver lining. It's possible that other civilizations, having navigated past their great filters, are thriving in distant corners of the cosmos. Their successes could eventually pave the way for us to communicate, collaborate, or even coexist. Furthermore, life in its most rudimentary form might be closer than we think. Entities not yet sophisticated enough to establish contact might inhabit realms within our reach. Our quest might not always lead us to advanced civilizations. Even the discovery of microbial life would be groundbreaking. Amidst all the speculation and theories, one thing is certain. Our thirst for knowledge remains unquenched. The scientific community remains undeterred in its mission. With every passing day, we probe further into space, and particularly our solar system, hoping to unearth evidence of life. Discoveries, such as water on Mars or conditions suitable for life on some of Jupiter's or Saturn's moons, emphasize that we might not have to venture too far to find hints of life. The universe, with all its vastness and mysteries, continually beckons. We remain eager to uncover its secrets. As we continue our journey through the vast expanse of the universe and its mysteries, your support and curiosity drive us. If you want to stay updated on more such revelations and insights, make sure to subscribe. Together, let's keep exploring the unknown. Don't miss out. Hit that subscribe button now.
Let's test to see how many spiral-shaped objects you can find around you right now. I'll bet there's more than you think. A spiral may be hidden in the flower petals of your houseplants. One might be staring at you from that seashell you brought home from your last trip to the beach. If none of these objects sound familiar, you might want to head over to the mirror and turn to the side a bit. In case you haven't noticed yet, even our own ears are shaped like a spiral. Why does Mother Nature seem to have such a preference for this shape? Many theories wish to explain this weird behavior. One of them is based on the Fibonacci sequence. This Italian mathematician didn't really care much for spirals initially. He was studying rabbits when he came up with this theory. Fibonacci came up with the sequence as a solution to a problem involving the growth of a population of rabbits. Let's recreate his experiment. If you put a pair of rabbits in an enclosed space, how many pairs of rabbits will you find there after a year? To solve this problem, Fibonacci proposed some conditions for his theoretical experiment: that all rabbits are born as a pair, one male, one female. Also, the rabbits can start reproducing after 1 month. More so, each pair of rabbits produces one pair of offspring each month. And lastly, none of the rabbits kicks the bucket at the end of the year. Now, using these assumptions, Fibonacci noticed the following sequence: 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. The first two numbers in the sequence, 1, 1, represent the initial pair of rabbits. The next number, 2, represents the number of pairs of rabbits after the first month, one pair of the initial rabbits plus one pair of offspring. The fourth number, 3, represents the number of pairs after the second month, 2 pairs of the initial rabbits plus one pair of offspring, and so on. He soon noticed that his series is made out of numbers in which each number is the sum of the previous two numbers. A lot of other mathematicians have looked at this sequence over the years. They were soon surprised to discover that this system was found in many natural structures, such as the arrangement of leaves on a stem and the arrangements of seeds on a sunflower. If you don't understand why it is so, then grab a piece of paper and a pen. Together, let's try to draw the Fibonacci spiral. You'll have to start with a small circle at the center of your page and then draw larger circles around it without lifting the pen from the paper, using the numbers from the Fibonacci sequence. For example, the first circle is 0 units wide, the second circle is 1 unit wide, the third circle is 1 unit wide, and so on. As you keep adding more circles, they will fit together perfectly to form a spiral shape. The spiral gets bigger and bigger, but it always follows the same pattern based on the Fibonacci sequence. Another famous spiralist was a man named James Bell Pettigrew. He was a Scottish naturalist that became fascinated by the mystery of the spiral shape, which he noticed almost everywhere in nature. He studied it at all scales, from giant nebulae in space to tiny molecules. Despite his research, he couldn't figure out where the spiral came from. He was sure that it couldn't be just a physical thing, and he believed that organs in plants and animals are not only shaped like spirals, but they also work in a spiral way. At the center of lifetime work on this unique shape was the human heart. Pettigrew believed that the heart's spiral structure was the mystery of all mysteries. He also thought this shape was to blame for both its muscular contractions and how the blood seemed to travel within our mighty tickers. The reason why the spiral seems to be everywhere might be really simple: efficiency. Take a look at the basic sunflower, for example. It figured out a way to display its seeds so that it could expose them to the sun equally, without wasting any space and without being limited in their growth. Spiral stairs are another great example too. They just work better. You find it easier to climb them, and they should take less space than the usual ones. We also might be more inclined to notice this shape more than others. That's because a spiral shape, or its proportions, is more aesthetically pleasing to the human eye. It's the reason why interior designers, artists, or illustrators often use these principles in their work. The spiral symbol is also the oldest symbol found in every civilized continent. Some historians believe that the spiral in Asian art may represent the sun, as it has been found on roof tiles from the Tang dynasty near the ancient city of Chang'an. It is also often found at burial sites, and scientists believe it to represent the circle of life, how we pass on and somehow be reborn. This is probably because in some ancient civilizations, people believed that the sun was born each day, extinguished itself each night, and was reborn the next day. You might have also stumbled upon the spiral as a symbol of hypnosis and dizziness. There's no real evidence that you can hypnotize someone by making them stare into a spiral for a certain time. But its effects on our abilities to focus and our optic nerves are significant. After you've stared at a spinning spiral for quite some time, you'll notice how objects either get smaller or bigger, depending on the direction of the spiral. It's easy to understand why some experience the sensation as hypnotizing. One of the most distinctive features of DNA is its spiral shape. It's also called a double helix. The double helix is formed when two strands of DNA twist around each other, like a ladder being twisted into a spiral shape. This spiral shape is important for many reasons. First, the spiral shape allows DNA to be compact and efficient. The double helix can pack a lot of genetic information into a small space, making it possible for cells to store vast amounts of genetic material in a small area. Second, the spiral shape allows DNA to be flexible and respond to changes in our environment. Because the double helix is made up of two strands that can move relative to each other, our DNA can change its shape. Finally, the spiral shape of DNA allows it to interact with other molecules in the cell. Now, let's look at the big picture. The biggest of them all, that of the galaxies found in our universe. They're also shaped like a spiral due to their rotation and the presence of dark matter. As the galaxy spins, the stars and gas clouds within the galaxy move in a circular direction around its center. This movement creates a spiral shape as the stars and gas clouds are drawn toward the center of the whole system. Additionally, the presence of dark matter, which is a type of matter that does not interact with light, creates gravitational forces that help to shape the galaxy into a spiral. But you don't need to look that far to understand why spirals are important. Your handy corkscrew is shaped like a spiral too, because it makes it easier for you to open the wine bottle. That screw you drilled into the wall to hang a picture, also a spiral. It helps it with some added grip and stability. Got a notebook on your desk? Those pages might be held together by a spiraled wire. It makes it easier for you to browse the notebook without damaging the pages. Even your hair strands might have a curled shape. The curlier the hair, the drier it will be. It means it will get sebum from the scalp down on the strand slower, making it easier to maintain and clean. And before I spiral out of control,
84 million years ago, many modern mammals, birds, insect groups, even the first flowering plants are already there. Dinosaurs are still roaming around. They have around 20 million years left before the asteroid. T-Rex, a fearless hunter, becomes the king of the dinosaurs. In the Earth tilted by 12 degrees. Picture our planet as a chocolate truffle. The shell is hardened, the center is viscous, with semi-solid matter. Its top layer, the crust, consists of tectonic plates that are like puzzles. Continents and oceans come on top of these plates. 84 million years ago, the mantle and the crust started rotating around our planet's outer core, then going back. If you'd been able to see it from space, it would have seemed like the entire planet has tipped over on one side. Today, it would have moved New York City to where Florida is. Let's say our planet is like a spinning top. It whirls perfectly if the weight on the top is evenly distributed. But if you move some of the weight to one side, it makes it tilt. It may have been caused by the moving of the tectonic plates and one of them sinking under another. We might be drinking water older than our solar system. Some scientists think the water we have on Earth may have come from ice specks that were floating in some sort of a space cloud more than 4.5 billion years ago. Lakes aren't always peaceful and relaxing. They can also explode. It happens when there are volcanic gases under the surface that can burst, rise to the surface, and cause big damage. The Earth's rotation is slowly going through time. Every year, the moon gets a little bit of energy from our planet and slowly drifts farther away from it. These two things are making our day longer, but really slowly, around 1.4 milliseconds every 100 years. That means when dinosaurs were around, the day was 23 hours long. Our planet used to be purple. One theory says ancient microbes didn't rely on chlorophyll to absorb the sun, but on different molecules. They absorbed green light and then reflected back a nice purple color. Every time you take a dip in the ocean, remember you're swimming above more than $700 trillion worth of gold. Not on the ocean floor waiting for someone to get it out, but in tiny particles dispersed in the water. The deepest place on our planet is the Mariana Trench, a spot in the Pacific Ocean, 36,201 feet under sea level. But the deepest place that's not covered in the ocean is in Antarctica. Technically, it's hidden below thick and deep layers of ice, goes more than 8,300 feet below sea level. There are 60 tons of dust falling from space to our planet every day. You probably inhale a pretty good amount of this cosmic dust while just going to work. It's dust, small particles from comets, meteorites, and some other space bodies. Dalal, Ethiopia, is the hottest inhabited place on our planet. Between 1960 and 1966, the temperature was 106 degrees Fahrenheit, and even in the wintertime, the temperature goes up to 98 degrees Fahrenheit on average. 8 minutes and 20 seconds. That's the time sunlight needs to travel from the sun to our planet. It's still not that much compared to what it takes for the light to reach Pluto. 5.5 hours. Almost 70% of the fresh water we have in this world is held in ice sheets and glaciers. More than 96% of the total amount of water on Earth is in the oceans. The Earth is like some sort of big magnet. Its inner core is actually a sphere made of solid iron, with liquid iron surrounding it. All those variations and changes in density and temperature create some sort of force, which makes the iron produce electrical currents. They are lined up by the planet's spin, and together, they create a magnetic field. There are many stars in the Milky Way, 100 billion, but way more trees on our planet alone, around 3 trillion. You can tell how old the tree you're looking at is by its rings. They can also tell you more about the conditions of a given year, too. When these rings are thin, there was a drought, while the thick ones say it was a rainy period. Earth is a magical planet where even rocks can walk, at least some of them, in Death Valley, California. They leave trails so you can record the path they've passed. Some of those biggest rocks have left tracks behind up to 1,500 feet long. Smooth-bottomed rocks wander around, while those with rough surfaces tend to leave straight tracks. The world that surrounds us consists of atoms, and they seem to be solid. But 99.99% of them are just empty space. An atom is just a really small nucleus and a cloud of electrons surrounding it. These electrons are particles, but they act like waves. They don't exist in one point but are spread over a range of probabilities and occupy lots of space. Take the empty space in our atoms, and all the humans could fit in a really tight space like the volume of a sugar cube. Australia is slowly shifting north, 2.75 inches per year because of tectonic movements. Australia is one of the top continental tectonic plates that move faster than others. You'd need 400,000 moons to reach the level of brightness the sun has. Sounds a lot at first, but the moon only reflects the light coming from the sun. It doesn't make its own. And even though that's not enough, its brightness depends on the exact angle between the sun, moon, and the Earth. The planet we live on used to have 2 moons, or at least some scientists believe so. They figure the side of the moon that faces the Earth is relatively flat and low, while the other side is way thicker and crustier. The theory says that there used to be the second moon that collided with the thicker side. Some believe there's still a second moon. It could be not a giant space body we see clearly in the sky, but some sort of a small asteroid pulled into the Earth's orbit. Air doesn't mostly consist of oxygen. Almost 78% of it is nitrogen. If you want to see some pretty steep rocks, go to Canada, Auyuituk National Park. It has the biggest vertical drop in Canada, the tallest and the steepest cliff, with 105 degrees of overhang and 4,000 feet of rock. A team of 4 American men finally made it to the top in 1985, although there were 30 attempts for that before. It took them 33 days to get up. The Pacific, Atlantic, Indian, and Arctic are the 4 world's oceans. The 5th is confirmed to be the Southern Ocean. It's not defined by the continents around it, but by its Antarctic current that goes from west to east. Research shows this current was created more than 30 million years ago when South America and Antarctica had separated. This allowed water to flow around the bottom of the ocean without any barriers. Melting glaciers and ice sheets means more water in the oceans. It adds the extra weight of all that liquid pressing down the sea bottom, making it sink. The Earth's surface looks solid and kinda permanent, but every 500 million years, it goes through a process of regeneration. Tectonic plates crash into each other. Continental crust creates pressure on the oceanic crust, and that pressure activates the volcanoes. Through time, all this results in regenerating and replacing a majority of the Earth's surface, just like our body regenerates skin cells, replacing old with new ones. Out of all planets in the solar system, Earth is the only one with the outer crust that's broken up into huge surfaces we call tectonic plates. This is an important process that allows the formation of oceanic trenches and mountains, and also helps with protecting the Earth. When microscopic planets that live in the ocean are gone, they fall down to the bottom. The remnants go back into the interior of our planet and get recycled, and eventually end up in the atmosphere, protecting us from overheating and turning into Venus, the hottest planet in our solar system.